Where do we have on our notes? All right, I think we're front of the second page, I think. So talking a little bit more about pH and pOH, and then the calculations that we'll use with those. All right, so the pH scale indicates the hydrogen ion concentration. When something is in brackets, that means that you're using the molarity concentration. So hydrogen ion concentration of a solution. So how many ions are in a solution? If there are a lot of the hydrogen ions, then we consider it acidic. If there's just a few, then we would consider it basic. So just a couple of reminders. An acid, which starts with a hydrogen. If we're talking about hydrogen ion or hydronium, which is your H3O plus. I keep catching that silly little thing. Those all have to do with an acid. Also pH. If we're talking about base, then we're going to be talking about somewhere about a hydroxide. And then we can use that information to get pOH. And that'll become important because, like with the word problems, you have to decide whether you're looking at an acid or a base when you're given the strength, and then where you need to go from there. So the pH scale goes from 0 to 14, and it's a logarithmic scale. So that's why actually as your concentration gets higher, your pH number gets lower. There's also a pOH scale that looks at the hydroxide concentration, or how many hydroxide ions there are. And same thing, if there are a lot of hydroxide, we assume it's a base. And if there are very few, then it would be an acid, because hydroxide has to do with your base. The way that pH and pOH are related is that if you add them together, they equal 14, and we use that quite a bit because it's our way that we can kind of move between hydroxide and hydronium concentrations. So the two of them added up together equal 14. All right, I'm going to move this up a little bit. So pH range, like we said, it goes from 0 to 14. Anything from 0 to 6.999, right up to 7 is going to be acidic. If I am exactly at 7, it would be not basic, it would be neutral. And then if I did, like 7.01, just anything that's right over 7 to 14, then it would become basic. So lemon juice, if we look at lemon juice, it has a pH of 2, pretty low. So it is acidic. It's an acid. To get its pOH, I would do 14 minus 2, and that would tell me it would have a pOH of 0. Pure water has a pH of 7, so that means it has a pOH of 7, and that would be neutral. And then milk of magnesia, which is something for upset stomach, it has a pH of 10, so 14 minus 10 would tell me it would have a pOH of 4, and that would be basic. You always want to look at your pH numbers to determine whether something is an acid or base. because we'll also be using POH a lot. And if you looked at the POH, then it flips your answer. So we know that water can act as an acid or a base, and we said that means it is amphoteric. So water will auto ionize. That means when you have a glass of water, you're going to have a lot of the water molecules, which do not have a charge, but you will still have some ions of hydronium and some ions of hydroxide. And if you were looking at pure water, those would have to be equal to each other. That's the only way that you would get a pH of 7. So my hydronium, which represents the acid part of it, and my hydroxide that represents the base part of it, would have to be equal to each other to have a pH of 7. So that comes back to something called the Kw, or the ion product constant for water. And it says that Kw is equal to the hydronium concentration times the hydroxide concentration. And at 25 degrees, that value is 1 times 10 to the negative 14, I'm sorry, 14. But that is only at 25 degrees, because once you vary the temperature, then that's going to change how those two concentrations are related to each other, and then that would change that value. So we really don't use that number or that equation for really much during this unit, but you kind of just need to know what it is. So whenever you come up to higher classes of chemistry, you might be able to recognize it. All right, at the very bottom, I'm going to move that up some. We're looking at concentrations. Remember, the H plus has to do with an acid. The hydroxide has to do with the base. You okay, Gabby? Yeah, you need to. So whenever it's neutral, then it makes sense that the H plus concentration would be equal to the OH concentration. That's when your pH would be 7. When it's acidic, so less than 7, it makes sense that the H plus, which is representing the acid, is greater than the OH, because you have a pH less than 7. And then it would be switched the other way. If I have a pH greater than 7, so now I'm moving to a basic pH, then my hydroxide would have to be greater than my H plus. The part that represents the base would have to be greater than the part that represents the acid. All right. All right, so we're going to look at some different formulas that are used to calculate things about pH or POH. And just a couple of reminders. Like I said, we're going to acid, which you may or may not need to write down, starts with hydrogen. So if it's talking about hydronium or hydrogen ion, because those are used interchangeably, all of that goes with acid along with pH. Then my base is going to have a hydroxide. Whoops. I don't know what I hit whenever I do that. Base. I have a hydroxide. And OH. And POH would go with it. All right. So these are going to be our formulas that we're going to be using right here. These. And that little group right there. And I guess I should come down and get this. we also need that. So if this is one of your unknowns, so if you're trying to figure out the pH or if you're trying to figure out the pOH, then you would use these formulas. pH has to come from the concentration of the hydronium. We said those two go hand in hand. So if I needed to find my pH, I would take my negative log of my hydronium concentration, and that would give me my pH. Same thing, if I wanted to find my pOH, I'm dealing with my base. So now I'm looking at the negative log of my hydroxide concentration. Sometimes those concentrations will be given to you directly, like on your front sheet of your practice. Sometimes they're given to you as part of a compound, and then you have to be able to recognize that compound and know it's a base, know it has a hydroxide, and go from there. And then here, if these are my unknown, so now I already have my pH, I already have my pOH, I would use those formulas to find out the concentration. So 10, and then I would raise it up to negative pH for my hydrogen ion concentration, because that has to do with acids, or 10 raised up to my negative pOH, because that's for my hydroxides, my bases. And then, like I said, pH plus pOH always comes in handy. As far as significant figures for pH, when counting significant figures for pH, you only count what comes after the decimal of a pH or pOH number. So anything in front of the decimal, you don't worry about. You look at places behind the decimal and you see how many places there are. So 12.01, I have 2 places behind the decimal, so that means it has 2 significant figures. 12.0, I have 1 place behind the decimal, so that means I have 1 significant figure. So if you're given the concentrations like we are in this problem right here, that's going to determine my sig figs. If I'm given my pH or my pOH, that will determine my sig figs. All right, so we're going to look at this one. I have 0.001 molar sodium hydroxide. That's just 1 sig fig. It's a hydroxide, so it's a base. So that means I'm going to have to find pOH first. This is asking for a pH. I can't find that from a concentration of a base. I have to find pOH first, and then I can use this little relationship to get my pH. You also have to go back and you have to remember how they ionize. So in solutions, we talked about a strong acid or strong base will ionize in water. So if I ionize that, it's Na plus, and then I have 1 hydroxide. Neither the sodium or the hydroxide had subscript. So I'm just going to have, it's just a 1-to-1 ratio. So that means if this is 0.001 molar, then my hydroxide is 0.001 molar. All right, so we want to find, first of all, our pOH. So our formula is pOH. I'm trying to find pOH, that's my unknown, is negative log of my hydroxide concentration. That's my formula. And now we know my hydroxide concentration is 0.001 molar. So that's what you put in your calculator. Negative log, just the negative sign, the regular log. It'll give you 1 parentheses and you would put 0.001. So if you'll try putting it in your calculator. And we got what? 3. And then we need to adjust for sig figs because we said we needed 1 sig figs. It's going to need to be 3.0. And remember, that's my pOH. So now to get my pH, I just need to do 14 minus 3.0, and that would give me 11.0, and that would be my answer. That would be my pH value. So once again, the reason I had to go to pOH first is because I was dealing with a hydroxide, which is a base. If I would have been dealing with an acid, I could have gone directly to pH. All right, anybody have any questions about that particular one? All right, let's go over to the top of the next page where it says pH practice. We'll look at some more examples over there. All right, so it says, what is the pH of a 3.4 times 10 to the negative fifth molar hydrochloric acid solution? So the first thing I notice is that's an acid. So that means I can go to the pH directly. I don't have to go through the pOH. I also notice this is, how many sig figs? 2, 3.4. So that would be 2 sig figs. So that means when I get my pH, it should be 2 places behind the decimal. And then the other thing I notice, there's only 1 hydrogen. And what that means is that if this is 3.4 times 10 to the negative fifth, then my H plus is also 3.4 times 10 to the negative fifth molar. And in a minute, I'll show you one on the worksheet where you have to, where it's not just 1, it's 2. But you don't need to write this equation. Like what you need to glance at is like my hydrogen, is it just 1 or is it more than 1? My hydroxides, is it just 1 or more than 1? If it's more than 1, then you're going to have to multiply that by however many you have. All right, so those are kind of all my things that I noticed. So once I've done all that, I'm going to find the pH, which I can do directly. And my pH, if you look at your formulas, if I'm trying to find my pH, it's going to be negative log of my H plus concentration, which is what I have right here. So 3.4 times 10 to the negative fifth. And that's what you would put in your calculator. And we said we should have 2 places behind the decimal so I can have 2 sig figs. But we want 2 sig figs, so we're going to do 2 places behind the decimal. So what would you get then? Yeah, 2.47, right. And that is my pH. So that means that answers my question. And the reason it's this is, I know it's, it's weird because this looks like 3 sig figs to us, right? But when you're looking at a pH number or a pOH number, for some reason, that doesn't count. It's just the places behind the decimal. So that's why we needed those 2, because it's a little bit different. So 4.47. And no units. So I wrote pH just to keep it clear, but there really are no units for pH or pOH. Next one says, what is the pH of a solution if the pOH is 5? What would that be? What's our relationship between pH and pOH? What do they add up to equal? 14. So if I do 14 minus 5, I would get 9. That pOH didn't have anything behind the decimal, so my pH wouldn't have anything behind the decimal. All right. The next one says, what is the pH of a 10 liter? And if you'll make that 10 with a decimal behind it, because so it'll have 2 sig figs. I hate working with just 1 sig fig. So potassium hydroxide, so it's a base. And then it shows how many grams I have of it. So one thing I noticed, it's a base, so I can't find pH directly. I have to do pOH first. And nowhere in there does it give me the molarity of that KOH, but it gives me everything else I need to figure out the molarity. So I would use my grams and the molar mass of potassium hydroxide to convert to moles first. So the molar mass of potassium hydroxide is 56.11 grams per 1 mole. So at this point, I have 4 sig figs, although that'll change eventually. But right now, because of that, 4 sig figs, so 0.1000 moles. And my formula for big M is moles per liter. So I take that and I divide it by how many liters I had, which was 10. And because of that 10, I go down to 2 sig figs. So now I have 0.010 molar. And that is of my KOH. All those calculations were done on the potassium hydroxide. And once again, that's just one hydroxide. So that means if that is the concentration for the original solution, it's also the concentration for the hydroxide. So my formula is going to be, if I want to find POH, it's going to be negative log of my concentration, 0.010. And I have 2 sig figs. So whenever I do that, I should report my pH with 2 places behind the decimal. So what do we get? 2.00. So that's my pH. And I'm sorry, that's my POH. But of course, that doesn't quite answer the question. We want it in pH. So what would my pH be? 12.00. 14 minus 2 would give me my 12.00. All right. Move that up a little bit. So the next one, the last one, I want y'all to give it a try. We'll kind of talk about it a little bit. I know the pH, and that's potassium hydroxide, so that's a base. So it's asking what is the molar concentration of the solution. So that's asking what is my hydroxide concentration, what is the POH, and what is the H plus concentration. So you're going to be using some of your other formulas. You're going to have to flip over. You have your pH. It's going to be very easy to get your POH. What are you going to do? Just subtract it from what? 14. Once you have those, then you're going to need to go to your other formulas. I don't think we've used them yet. The ones that you get your H plus concentration or your OH concentration. So I'll give y'all a few minutes to give that a try. First step would be finding your POH. Ronnie, what do you need to do to get your POH if you know your pH already? From 14. So do that first. That's going to be your first step. So 14 minus 10.75. So once you've done that, oops. Where are you at? So you can see once you've done that, then you'll be able to use those formulas to get your two concentrations that you need. Your H plus concentration, you would just take it 10 and raise it up to your negative pH. And then your hydroxide, same thing, but you would raise it up to your negative pOH. I don't think we've used those on any examples yet. So we have our pH is equal to 10.75. And then our pOH would be 14 minus that. So what did that give us? 3.25. So I need my two concentrations. We haven't used those formulas yet. But remember, H plus goes with pH. So that formula was 10, and then I raised it up to my negative pH. So that would be negative 10.75. It's two places behind the decimal, so I have two sig figs. So when I get my H plus concentration, I want two sig figs. And you'll probably on most of your concentrations, not on your pH or pOH numbers, but most of your concentrations, you'll probably have an exponent with a negative exponent, a very small number. So what did we get for that one when we plugged it in into the calculator? How about 1.8? Did I round wrong? That is always a possibility.
Online, that can be a possibility.
Yeah. See how we got, if you, it's 1.778 something. So if I just do 2, I'm going to round it to 1.8 times 10 to the negative 11th. And it's molar. That's the concentration. And then I would do the same thing, but now my hydroxide, so I have to use my pOH. So 10 to the negative 3.25, and that's what would go in my calculator. 10, I call it the little carrot top, minus 3.25. So 5.6 times 10 to the negative 4 molar. So those four things are related. So if I know one, and you could add in there whether it's an acid or a base. If you know one of those, you can figure out all the other ones using these little formulas that all just kind of go in your calculator. All right, so let's look at on your practice. So the first page is just practicing using the different formulas. It's very straightforward. You don't have to read a word problem. So I don't know if you want to write down your formulas so you don't have to flip back and forth. I'm going to do that. So my H3O plus would be 10 to my negative pH. And then my OH would be 10 to my negative pOH. So that's if your unknown is your concentrations, because that means you would already have pH and pOH. Then if I want to find my pH, it's negative log of my H3O plus concentration or POH is negative log of my OH concentration. So that's if your unknown or what you're missing is your pH or your POH. And then, of course, pH plus POH equals 14. Also, we use a lot. All right, so let's start here. You can see there's 5 things. I need one of them to figure all the rest of them out. So I have my pH. So the first thing I would do, I would say, okay, pH of 3.78 makes it an acid. My next thing that I would do is I would probably go ahead and get my POH because it's also easy. So 14 minus 3.78 would be 10.22. That's 2 sig figs. So now I have everything. What I'm missing are my concentrations. So now that means I'm going to be looking over here for these formulas. So my first one, my H3O plus. So I'm going to have to do 10 raised up to my negative 3.78. And I get 1.659. So I only wanted 2 sig figs. So I would say 1.7 times 10 to the negative 4. And then since it's a concentration, I would put M for molarity. Like I said, you're going to have a lot of negative exponents on the concentrations. Now I need my hydroxide, so I use my formula here. 10 raised up to my negative POH. Negative 10.22. Still 2 sig figs, so 6.0 times 10 to the negative 11 molar. And then you can kind of just take a glance and look at your numbers and see if they make sense. This is an acidic solution. So does it make sense for my hydronium to be a negative 4? I know that's a small number, but it's not nearly as small as a negative 11. So does it make sense at a pH of 3.78 for my H plus concentration to be higher? Yes, it does, because doesn't H plus go with pH? So that makes sense. Remember, your H plus and your pH go together. Your POH and your OH go together. And then, like I said, just be sure you look at your pH number here to decide whether it's an acid or base, because you can see your POH, and at that, it would flip it. So the first sheet on here is mainly just getting you to get comfortable with the formulas and moving through them. I wanted to show you one on the very last page. Evidently, I didn't pull up the right one. Let me do that. On the very last page where it just gives you a little bit of information, and then you're finding pH and POH, I think. I wanted to show you one where you would have either more than one hydroxide group or more than one hydrogen. I think we right here. So this is the very last one, very last page. So you can go through and you can write the formulas for these. And you can see most of them have one hydrogen, one hydroxide. So I don't need to really do any, anything. That means if I only have one hydrogen or one hydroxide, that means this concentration of the original solution is going to be the same. But on barium hydroxide, that one is BaOH2. So that means when it ionizes, I end up with a barium 2 plus, but I have 2 hydroxides. And if you go back to whenever we talked about solutions, I have to take the original concentration and multiply it by the coefficient. So I would have to take 0.000901 times 2, and that would give me 0.00180, and that would be my concentration that I would have to put in for my hydroxide. So instead of using this for my hydroxide, I would have to use it doubled because I had 2 hydroxide ions. So that's a lot of times that's not going to come into play, but like here you have sulfuric acid H2SO4, you're going to have to do that same thing. That means you're going to have to double the original concentration when you use it as your H plus concentration. I just wanted to show y'all one of those. All right, that gives y'all about 5 minutes to kind of maybe work on the front page and get more comfortable with the formulas. Tomorrow we'll do the quiz. Y'all have some more time to work on it, and we'll end with a lesson check, which will be graded as a daily grade.